The topic me and my partner chose to present is a hands-free hand sanitizer. This was created in response to the current COVID-19 pandemic that has affected the entire world at large. Hand sanitizers have been around since the 1960s. They were created in response to the inability of many people being able to access water and soap. Hand sanitizers are mostly composed of alcohol and a small percentage of water. The amount of alcohol is usually upwards of 70%, and this is what aids in killing the germs on one's hands. This brings us to the current pandemic known as COVID-19 or coronavirus. COVID-19 is the new global pandemic which has spread to every single country in the world, and health officials are advising that the best way to prevent the spread of this disease is by constantly washing your hands. It isn't feasible for a person to wash their hands every time they touch a surface. This is why hand sanitizers are a great response to this, as they can kill most of the bacteria living on your skin. Keeping your hands clean will not only prevent yourself from getting this virus, but will also aid in eliminating the spread of this virus. What makes our product different? On the left, you can see what a conventional hands-free hand sanitizer looks like that is currently available on the market. On the right is the prototype we created for our hand sanitizer dispenser. What makes our product unique are the specific components used to create this dispenser. We included an ultrasonic sensor, which was key in making our product different. Current models of hand sanitizer dispensers often place a cheap sensor at the location of the dispensing nozzle. We run into a problem with this situation due to the fact that these sensors don't have a proper range of motion built in. This forces people to wave their hands under the sensor, and oftentimes people end up touching the dispenser in an attempt to sanitize themselves. Many people touching the dispenser means that this has become a location where the spread of germs has been enabled. In our current situation of this global pandemic, this is the last thing we want. Here you can see the parameters of the ultrasonic sensor we chose to use. What's important here is the range of motion of the sensor. Its range of motion works anywhere from 2 centimeters to 4 meters. When programming our sensor, we took into consideration that if you're too close or too far, the sensor will not trigger. This is to prevent people from getting too close and possibly infecting our dispenser. We came up with an optimal range of motion of 3 to 5 inches and embedded this into our program. Here's the timing graph that is associated with our sensor. The sensor sends out 8 cycle bursts of ultrasound at 40 kHz. This will raise the echo feature. The echo is one of the 4 pins that this sensor is comprised of. The echo acts as a distance object that proportions the pulse width as well as the range of motion. To prove our concept, we conducted an experiment to see, during this pandemic, what would people prefer. We created a comparison between a manual hand sanitizer bottle and an automatic dispenser and placed them next to each other. Both were filled 100% as is displayed in the graph on the left. After a week, we looked to see what the results were. Turns out the conventional bottle of hand sanitizer still had 75% of its contents left, and our automatic dispenser had roughly 30% of its contents left. This goes to show that due to the coronavirus outbreak and the spread of germs becoming rapid, people would prefer our dispenser as opposed to the conventional bottles available on the market today.
Hi, so my name is Azam, and I'm basically going to do a demonstration of all the schematics that were used and all the basic elements that were used in the construction of this project. So there are a lot of different elements that we've used. The main ones were going to be the ultrasonic sensor, which is over here. We used a 9G microservo, which is over there. We used a breadboard, and we used the Arduino Uno, and we used a bunch of different jumper wires as well. So the most important element of this project, I'd say, would have to be the ultrasonic sensor, which is this one over here. And the purpose of this element is basically that when you bring your hand close to it, it's supposed to trigger the 9G microservo to switch off, and as a result, it can basically pull down on the hand sanitizer pump. So to understand a bit more about the ultrasonic sensor, if you look closely, there are these 4 specific slots that come with it. There's a VCC, a trig, an echo, and a ground. So the VCC, it basically means that it's a 5-volt supply. The trig is going to be basically, it's going to send out a signal. The third one is going to be the echo, and this is basically which receives the signal. And then the last pin is the ground, and that basically is ground. So to basically wire this, I have attached the ultrasonic sensor onto the breadboard, and then I've had a bunch of different jumper wires that are basically connected from the specific slots associated with the ultrasonic sensor to various different elements on the breadboard and the Arduino. And the basics of this is that I've powered the Arduino by attaching it to the breadboard and basically using this as a power supply. So to basically understand all of this, the 5-volt wire from the ultrasonic sensor, it was connected to the positive slot on the breadboard. Then the next slot was the trig wire, and this was connected to pin number 7 on the Arduino. Then the third slot was the echo wire, and this was basically connected to pin number 6 on the Arduino. And then lastly, it was the ground, and this was connected to the negative. Ground is over here, and that was connected to the negative slot on the breadboard. And then we have the 9G microservo over here, and this is the purpose of this is basically that once somebody's hand comes in close contact, or close range I should say, to the ultrasonic sensor, then this switch is supposed to switch all the way down, optimal 180 degrees, so that way it can pull down onto the lever that we have over here that's connected to the top of this pump. And the basis of this 9G microservo is that it comes associated with 3 specific wires. As you can see, there is an orange, a red, and a brown. And each of these wires, they have specific meanings to them. The brown wire is a ground wire. The red wire is a voltage wire. And the orange wire is a signal wire. So to basically wire this, I took the brown wire and I connected to the negative on the breadboard. The red wire, I've used that and I've connected it to the positive on the breadboard, and the orange was connected to pin number 5 on the Arduino. And then basically I plugged in the port to my computer, and this is the code that I used. Just a basic understanding of the code that I used. And this basically allows us to implement our whole strategy that when a hand comes in close contact with the ultrasonic sensor, then the 9G. So yeah, the ultrasonic sensor, it's gonna be connected to a bunch of jumper wires, and that are gonna be connected to the ultrasonic sensor. So when a hand comes in close range with the ultrasonic sensor, that is gonna trigger the 9G microservo to switch down and thus pull onto the strings that we have attached over here to the top of the pump, and that's gonna pull on the pump and release the hand sanitizer. And to show this, I'll just do a quick demonstration of how this switch should work. As you can see, hand coming in close range with it should trigger the 9G microservo to switch down, as you can see. Okay, so I'm just gonna basically describe how the project will work. You have the ultrasonic sensor over here, the 9G microservo over here, and I'm basically gonna demonstrate how it would work.